Hello dear students, in today's class we will be discussing the resolution of vector concept. So first of all, many students get doubt actually, sir, why we need to resolve the vector? And some students will get doubt, they'll ask, sir, should we resolve vector into two components or should we resolve a vector into three components? Children, it depends whether you are taking that particular vector in a plane or a space. Plane is a two-dimensional, space is three-dimensional. If we are studying the motion of a particular what we can say a particle or a motion of what we can say, if you are talking about the vector, so-called some vectors, especially you are discussing, you are studying in a plane, then obviously we will get two components. Whereas if you are studying about the vectors in a space, children, obviously you will get a three components. So it depends whether we are studying about the vectors in a plane or a space. So in today's class we will be talking about the resolution of vectors strictly in a plane only. Hope it's clear whether it's a two components or three components, depends on whether you are studying, whether you are taking in a plane or a space. Clear? Fine. And one more point, one more doubt actually, why we need to resolve the vectors? Okay, to understand this, to get a clarity about this point actually, let us take a small example, children. So for suppose here particular point O, let us consider the motion of one particle. That particular motion we are taking in this board plane, right? Okay, so let us consider such that it is moving in this direction. Let us say that, okay, initial let us say is going such a way that it is making some angle theta with the horizontal, okay, and here is a vertical line. Obviously, so for sake of convenience, let us say it's x, y. So we are taking x, y axis. Is it clear? Fine, children. Let us say after time t1, the particle has reached this point. Let us name it as a point A. Means at this point A, after reaching here, if you can see, it has covered some displacement along x axis. At the same time, it has covered some displacement along even y axis also. But do you think that this x1, y1 values are constant? No, because the particle is in motion and the time also passes, right? Okay, after some more time, let us say that it has reached a point B. Then if you can see from the origin, it has some displacement x2, right? Look at here, it has displacement x2 and even it has some displacement along even y axis, let us say y2. Means here if you can see the particular motion of this particle in this plane, okay, now as a particle is in motion, children, it has some motion, even it has some displacement along x axis and as well as along y axis also, which means what, it has a two types of motion, horizontal motion and a vertical motion, right? So now we can resolve these particular, if for example if we can take the displacement vector from O to B, if it is a displacement vector, this displacement has some horizontal component and has some vertical component. So that is the reason why we are resolving into vector, why we are resolving that particular vector into two components here, so that to have a better study about the vectors. Is it clear? So it has some horizontal motion, it has some vertical motion. Actually, it has two types of motion. So it is covering some displacement along x axis, it is covering some displacement along y axis also. That we will calculate individually. Along x axis how much it is, along y axis how much it is, we will calculate. It might be a displacement vector, velocity vector, force vector, any vector you can take, the concept is same. Clear? Fine. Now children, as it is shown in the diagram, yes, for sake of our convenience, here we consider the velocity of the particle. See, velocity is a vector, right? Same concept here. Before it was like a displacement, now we have taken a velocity. See, as there is a change in the displacement, obviously there will be a change in the velocity also. So the particular particle has some velocity along x axis as well as it has some velocity along the y axis also, which means what, it has some component, velocity component along horizontal direction, it has some velocity component along a vertical direction also. So children, along the horizontal direction, let us take it as a Vx. So Vx is a horizontal component of this velocity vector, whereas Vy be the so velocity component along a vertical, what we can say is this vertical component is. So Vx is a horizontal component, Vy is a vertical component. Now the task is that how to calculate Vx, how to calculate Vy. It's very simple. Here we are going to use the concept of trigonometry. Children, let us take this point as a O and here is A. See, from here point A, yes, a projection is made on this x-axis. So let us name it as a B. Now if you can see here, OAB is a, what you can say, right angle triangle you are getting. So from that, OAB triangle, children. So from triangle OAB, see what we need to calculate? We need to calculate this horizontal component, right? So in this right angle triangle, this is the adjacent side. So in order to find the adjacent side, children, we will define the cos theta. So from this triangle, cos theta is equal to adjacent side OB by OA. So from this, OB is equal to OA into cos theta. So OB is what here? Vx. Okay. OA is what here? Magnitude of this velocity, that is V, and here is cos theta. So this is how we can calculate the horizontal component of this velocity in this particular case. Now how to calculate this vertical component? Yes, it's very easy to us to calculate. Even children, if you can see, here is a theta, means obviously this will be the theta, right? So from this point A, let us make one more projection on this y axis. Let us name it as a some OAB. Let us make it as a C. So in this triangle, children, in this triangle OAC, what we to calculate here? OC we have to calculate. OC is what here? Opposite side. So in order to calculate the opposite side, let us define the sin theta. So here from this OAC, sin theta is equal to, children, here it is OC by OA. So here OC is equal to OA into sin theta. So OC is what here? That is Vy. OC is Vy. So OA is magnitude of this vector, that is V into sin theta. So this is a vertical component. Children, this is how we can calculate the horizontal component and a vertical component. First of all, what is the resolution of vector, children? So simply it is the process of obtaining the components of a vector such a way that when these two components are added by using the vector law of addition, again we must get the resultant vector. Children, it is not our wish. It's not your wish, it's not my wish, not someone's wish, let us take components, it's not that. So again the two components are added by using the vector law of addition. Again we should get that particular, the basic, the initial, the resultant vector we must get. Clear? Fine. And here some student will get they'll by heart here. Always they'll think that horizontal component, like along the x-axis they'll think cos theta will come. Along the y-axis they'll think of sin theta will come. Children, that is a wrong actually. It is, don't by heart like that. It is not like along x-axis cos theta, along y-axis sin theta. No, it is wrong. So you are getting why it is wrong, right? Yes, let me take one more example. Children. For suppose here, look at here. Let me take a, yes, same, it is the x-axis. Let us say here is a y-axis. Let us take same velocity vector V. Velocity vector V it is taken. Such a that it is making an angle theta with the y-axis, children. It is taking a angle theta, it is making an angle theta with the now y-axis. Now horizontal component will be along the y-axis, vertical component will be along the x-axis. So here you should see actually with what axis that vector is making angle, along that direction cos theta component will come. This is how you should remember. I repeat once again. You have to see that particular vector with what axis it is making an angle, that along that axis cos theta component will get. So which means what here? So along this it will be V cos theta, with this it is a V sin theta. V sin theta. Again I am telling you children, it is not that always along the x-axis cos theta, along the y-axis sin theta. No, that is a wrong concept. It is. The correct concept is that what we have to notice? We have to notice that angle made. See here this vector is making an angle theta with the x-axis, so that horizontal component will be along the x-axis. So vertical component will be along the y-axis. But whereas in this case, this vector is making angle theta with the y-axis, so that horizontal component will be along the y-axis, vertical component will be along the x-axis. You will get. Is that clear? So this is how actually we can resolve the vector into two components. If it is a in a space, if it is in a space, what will happen? You also get a Vz also you will get actually. Vx, Vy, Vz. Is it clear? Fine. And here one more important thing, children. As I told you that here. Okay, so it's a vector Vx and here is a Vy. When you can add these two vectors, okay, now by using the law of vector addition, you should get the resultant vector. So Vx is the magnitude. It is along the x-axis. Along the x-axis, the unit vector defined is I cap. Along the y-axis, it is the j cap. So now resultant vector V can be written like this. That is Vx I cap plus Vy j cap. So this is how actually again we can obtain the resultant vector. Is it clear? Fine. Now here we will learn very important point. Just meanwhile you can copy this. This is V. Let us say that. Children, here one important point is that here the magnitudes of Vx and Vy are always positive, but simply Vx and Vy, that is horizontal component, vertical component, you cannot say that it is a positive always. It can be positive, it can be negative, it can be 0 also. Is it clear? Fine. Now if you can see now we are going to see the directions of Vx and Vy for different values of angle we will see here. So for suppose children, look at here. Here the velocity vector is along the x-axis. As it is along the x-axis, what is the angle, children? Angle made with the horizontal, it will be 0. As theta is equal to 0, children, here. So Vx will be V, very good, and it is a positive, whereas Vy will be 0, right, in this case. Okay. Now in the second case, the velocity vector is, let us say, along the vertical line, let us say. So here is, so then what is the angle made with the horizontal line? It's a theta is equal to 90 degrees it is. So when theta is equal to 90 degrees, children, here, so Vx will be 0, but Vy will be V, and it is positive. Try to understand, very important. The third case, if you can see here, velocity vector is making angle theta with the horizontal axis such that the what we can say the angle is in between 0 degrees, means greater than 0 degrees and less than 9 degrees. So in this, children, in this between 0 degrees and 9 degrees, both sin theta, cos theta are positive. So here Vx has some value and it is a positive. The Vy also has some value and it is a positive. Clear? Fine. Now it's it's the first quadrant, right? Okay. Now if we can see here, the velocity vector is in the second quadrant such that it is making angle theta. Okay. Either you can take with this, either with the horizontal axis you can take here, or vertical axis. It's not a matter here. Okay. Now in this case, if you can see here, Vx is negative, and Vy is positive. Vy is positive because in a second quadrant, if you can see, children, here cos theta is a negative and sin theta is a positive. Okay. Whereas in this case, so the velocity vector is lying in such a way that it is making angle theta with the negative x-axis. In this means theta is what here? In between 180 degrees and 270 degrees, right? So in this case here, Vx and Vy both will have some values and both are negative. Both are negative only. Okay, fine. And here look at here in the fourth quadrant, if you can see, the velocity vector is such a way that it is making angle theta with the positive x-axis. Okay. So in this case, the theta is lying in between 270 degrees and 360 degrees, right? So in this case, both Vx and Vy, they will have some components, they will have some values, but here Vx, that the horizontal component is positive, and here vertical component is negative. Children, try to understand the magnitudes of Vx, Vy are always positive, but here Vx is V cos theta, Vy is a V sin theta, right? Okay, so here this Vx and Vy sin depends on the angle for a different values of theta. Okay, na? So here vertical component is 0 here, horizontal component is 0, here both are positive, here both are negative. So one can be positive, one can be negative, one can be negative, one can be positive. Clear? Just copy this. Here is theta. Children, these are the best example to get a more clarity on the resolution of vector. Children, look at here. So let us say here this is the initial position of the simple pendulum and it is pulled with a certain force, let us say that, such that it is making angle theta with the vertical line. Okay. Now we know that here is a tension T is produced. Now tension is a kind of force, so it is a vector. It can be resolved into two rectangular components. Now look at here children. So here this is one rectangular component and here is one more rectangular component. So if you can see, here is angle theta, means obviously this will be the theta. So then t cos theta will be in this direction, t sin theta will be in this direction. Is that clear? Is that clear children? Fine. And here, you know, some students will think like this. These two rectangular components, always they should be along the x-axis and along the y-axis. No, that is a really misconception. It is not that, it is not compulsory that these rectangular components can be along the always x-axis and y-axis only. No, they can be, these rectangular components can be even other than the x-y axis also. So to understand that, let us take this wedge type example. Children, here let us say that here body of mass is placed on this inclination such that the angle is theta here. Now we know that the weight of this body will be acting vertically downward direction. Children, weight, we all know that it is a kind of force. So it is a vector. It can be resolved into two rectangular components. Now let us see in which direction do we get these rectangular components of the weight of this block. Okay, so children, if you can see here, yes, so this is one rectangular component and this can be one rectangular component. Is that clear? Fine. And you may get one doubt, sir, then which one will be what mg cos theta, which one will be mg sin theta? Yes, we are coming to that point only. As in that is a theta, right? So this is 90, theta 90, then this will be how much children? This will be how much? Try to understand, this will be, try to, very important. So this is going to be 90 minus theta. So this is 90 minus theta. As it is 90 minus theta, obviously this will be theta. This will be theta. As it is theta means what here? Horizontal component will be in this direction. So here we will get here mg cos theta. As it is mg cos theta, obviously this is going to be mg sin theta. So these are the two rectangular components of the weight of the body. Now if you can see here, these two rectangular components not along the x-axis and y-axis, right? So it can be in linear direction, but they are mutually perpendicular to each other. Now children, same situation, but here now we are considering the normal reaction. Yes, normal reaction also force only. It is a vector. It can be resolved in two components. Now let us see how we are going to get the what we can say components of this normal reaction. So here is the theta, right? Okay, fine. So look at here. Here is one component will be in this direction, and here is one component will be in this direction. But if you can see children here, so this is theta. It is theta means what actually? So very important. So here is theta, right? Then this will be how much? Children, try to think clearly. This will be how much? Then this is going to be 90 minus theta, and this will be what children? Theta. So this is a horizontal component. So this will be n cos theta and this will be n sin theta. Is it clear children? So rectangular components are possible even other than x and y also. Is it clear? Just copy this. We do a simple 2 to 3 numericals so that we get a command. Copy this. Kilometer per hour. So look at here. These are 3 simple numericals. So let us try this. First numerical children. In the 3 cases, we need to calculate the horizontal and vertical components of the given vector. Now look at here. So here is f of x. So f of x can be written as f cos theta. So f is given how much? It is the 30. And here is cos 30 degrees. So this is 30 into cos 30 is how much children? Yes, it is root 3 by 2. So this is 15 root 3 newtons is a horizontal component. Let us try to calculate the vertical component, children. Yes, vertical component will be f sine theta. So this will be 30 into sine 30 is 1 by 2. So this is going to be a 15 newtons. Children, it is as simple as that. This is how we can calculate the horizontal and vertical component. Here you should see only about that angle theta. And the second case, children, if you can see here, yes, theta is equal to 90 degrees. Okay. Then what is the, so it is a velocity vector, right? Okay. So here horizontal component will be v cos theta, but cos 90 is 0. So that particular vector doesn't have any component along the x-axis. And here y component, vy is equal to v sine theta. So this v is how much? 5. It is a sine 90. Sine 90 is 1 anyhow. So vy is 5 meter per second. That too along the y-axis only. And if you can see this third numerical, children, here aeroplane takes off with a 200 km per hour velocity such that it makes an angle 60 degrees with the x-axis. Now they are asking us to calculate the two components. Children, can you try this? Come on, try this. What is the value of Vx? What is the value of Vy? Come on, try and comment your answer. Pause the video. Come on. 1, 2, 3. Let us see here. So here Vx is equal to V cos theta. So V is equal to 200. This is cos 60. So this is 200 into cos 60 is 1 by 2. So Vx value will be 100 kilometer per hour. Whereas here Vy is equal to V sin theta. So V is equal to how much? 200, and here is sin 60. So 200 into sin 60 is how much? Root 3 by 2. So this is going to be 100 root 3 kilometer per hour. So children, so this is about the, in a simple way, about the resolution of vectors in a plane, children. Is it clear? Okay. So next class exclusively we will be solving the different numericals, and it's a variety kind of a numericals based on the resolution concept, which are very important for your board exams. It might be ISC or a CBSE or a intermediate board of intermediate, that is SSC, and it is also very useful for our students who are very serious about the NEET and JEE mains. Okay children, thank you so much. All the very best.